All right, let's jump right in. We're about to explore a pretty wild new theory of the cosmos. I mean, what if everything we think we know, space, time, even the fundamental forces of nature, is all built on some kind of hidden, geometric, crystalline structure? Yeah, the whole thing starts with this absolutely massive, kind of mind-bending question. What if our entire universe, and I mean everything, you, me, the stars, all the galaxies, what if it's all just one single quantum particle, just kind of floating around in some much, much larger super universe? Now, if that's true, it completely flips our whole idea of the Big Bang on its head. We're all used to that classic expanding balloon model, right? Where the fabric of space itself is stretching out. Well, this theory says, nope, forget that. It says our universe is more like a quantum wave packet. So the Big Bang wasn't some explosion in space. It was the moment our entire universe particle was pinpointed at a single, certain location. And the expansion we see today? That's just its quantum uncertainty, its wave function, spreading out over time. Kinda cool, huh? But hey, this isn't just some fun little thought experiment. The whole reason this model is so compelling is because it claims to solve some of the biggest, most frustrating puzzles in all of cosmology. Specifically, it takes on two of the biggest unsolved mysteries in physics. First up, you've got dark energy. Why on earth is the universe's expansion speeding up? It should be slowing down. And then there's the hierarchy problem. I mean, think about it. Why can a tiny little fridge magnet overpower the entire gravitational pull of planet Earth? Why is gravity just so ridiculously, bizarrely weak? Okay, so the theory's solution to dark energy, it's pretty epic. We're talking about a cosmic car crash. It proposes that our little universe particle got slammed into by another one. So that acceleration we're measuring, it's not some mysterious energy pushing everything apart from the inside. No, it's the gravitational pull from that other universe, literally tugging us towards it. It's not a push, it's a pull. And what about that whole weak gravity problem? Well, the answer here is just so simple, so elegant. Gravity isn't actually weak. It's just leaking. Yeah, and the mechanism for this is really fascinating. The idea, which actually builds on something called the Randall-Sundrum model, is that gravity is made of these tiny closed loops of string. Now, unlike pretty much everything else, these little loops aren't stuck to our universe. So most of their actual strength is literally seeping out into the gap between us and that other universe, a place they call the bulk. What we feel here, it's just the tiny fraction that's left over. Okay, so let's recap. Our universe is a particle, it got smacked by another one, and it's leaking gravity. But what is our universe actually made of? This is where we get to the absolute heart of the theory, a brand new and very specific blueprint for reality itself. So the theory proposes that space-time isn't some smooth, continuous fabric like we usually imagine. Instead, it's a rigid, geometric crystal lattice. You should think less like a stretchy sheet of rubber and way more like the ordered atomic structure of a diamond. This idea of a kind of pixelated reality, well, that's the key to everything. And believe it or not, it all boils down to this one single number. According to the supercomputer simulations they ran to build this model, negative 139.54 degrees is the secret sauce. It's basically the fundamental constant that defines the entire structure of our universe. So what does that number even mean? Well, it means our universe exists in a state of permanent geometric tension, or strain. See, all the physical matter in our reality is built on this strained five-sided crystal structure. But at the same time, the fundamental laws of physics are trying to force everything into a more ideal, perfect nine-sided shape. Our entire existence, everything we see, happens in that tension, that friction between what reality is and what the laws of physics want it to be. And this is where the theory's predictive power just gets stunning. Because when you do the math on this geometric strain, you get these numbers. The model predicts that 73.7% of the universe's energy should be active, and 26.3% should exist as this sort of geometric shadow. And folks, that is an almost perfect match for the actual measurements of dark energy and dark matter that we got from the Planck satellite. It's uncanny. And this crystalline structure provides a framework for everything, because the theory goes even further. It redefines the four fundamental forces of nature. They're not particles being exchanged back and forth. No, they're just different kinds of mechanical stress inside this cosmic crystal. So the strong force, that's just the lattice's rigidity. The weak force, it's like a chiral filter. Electromagnetism, that's what happens when the lattice slips, kind of like friction. And gravity, as we already talked about, is the leak. And here's the real kicker. For every single one of these claims, there's a real unexplained anomaly in public data that this model suddenly explains. Everything from strange pentaquarks to the ongoing Hubble tension. It's like a master key.
Okay, this is all an incredible theory, but you gotta ask, is there any hard evidence? I mean, if our universe really did get smacked by another one, surely it would have left a mark, right? A bruise?
Well, it turns out cosmologists have found something that looks exactly like, and this is a direct quote from a researcher, a bruise from a collision with another universe. Its official name is the CMB cold spot. It's this massive patch in the sky that's just way, way colder than it has any right to be.
But here it is. Here's the smoking gun. When astronomers measured how gravity bends light around this cold spot, they found what they call a lensing anomaly. And what that means is that gravity in that one specific spot is 30% weaker than all our models say it should be. 30%!
And this is the crucial point. The crystalline universe theory just looks at that data and says, well, of course it is. That's the point of impact. That's the crack in the crystal. It's the exact spot where gravity is leaking out the fastest. It just fits. Now, the really great thing about this whole theory, unlike a lot of other multiverse ideas, is that it makes concrete, testable predictions. We could actually prove or disprove the whole thing. First, there's the lattice test. Scientists could look for gamma rays from distant explosions that arrive just a tiny bit late, almost as if they tripped over the crystal structure of space-time itself. Then there's the leakage test, which you could do right at the LHC. Physicists could smash particles together and look for collisions where a tiny bit of energy just vanishes. Poof, leaking out into the bulk. And finally, the scar test. Astronomers could look for a specific, telltale twist in the light that's coming from that CMB cold spot. 3 clear tests. But wait, there is one last, really profound implication that came out of all those computer simulations. And this one really changes how we see our place in the cosmos. It turns out, a right-handed version of this crystalline universe is just mathematically unstable. It would just explode. The numbers show that the only way for a universe built like this to actually survive is for it to have a fundamental, built-in, left-handed twist. And that cosmic asymmetry, well, it might just be the ultimate reason why life itself, right down to our amino acids and our DNA, has a fundamental left-handed preference. Think about that. Our very biology might just be a direct reflection of the underlying geometry of the entire cosmos. It's where cosmic law meets the blueprint of life. So, in the end, that's the big question this whole theory leaves us with, isn't it? Are we living inside some kind of perfect, logical computer simulation? Or is our reality something a little more organic? Maybe a beautiful but imperfect crystal, defined not by flawless lines of code, but by the constant dynamic strain between what it is and what it's always striving to become. Something to think about.